Hi, I got a question. It's more like a comment, an interesting actually. From someone who watched some videos and made some comments about iliac flow limitations. So basically, blood flow, um, uh, basically blood flow to your working legs to the iliac artery and NIRS, and actually sent a paper which I'd read before, but it is an interesting paper, and I've got it right here. It's near infrared spectroscopy is promising to detect iliac artery flow limitations in athletes, a pilot study, and it's actually a great good paper to read. It's interesting. They show some good data. Again, it's considered a pilot study looking at how NIRS can help identify some of these things, and there's definitely potential there, and I'll put some pictures up in the study so you can kind of get an idea, and then we'll talk about some data that we've collected as a group too, with a cardiologist from Prague that I know, Yuri Dostal. So first, what we see in the paper, they show this ultrasound, and you see that there's some that flow limitation in the iliac artery here is compromised, and they highlight that out. You see these circles and these squares, and they show kind of kinking and lesions in the iliac arteries. And the question is, well, if you have this, how's that going to have an effect on your NIRS signal? And you would assume that, well, you're going to have less blood flow, and for the NIRS perspective, then you'd have more trouble supplying oxygen. And they show that here. So they have a comparison to the healthy subject, and you see this right and left is kind of the same. But then you look at gotta make sure I'm looking at this chart right. Then you look at the affected leg or the patient with the lesion. You see that the affected leg and the unaffected leg have very different patterns. And they highlight actually that the recovery is the main difference. So they have that circled here in the graph, that the recovery is much slower. You see this big delay in recovery. And they're blaming this on blood flow limitations because of this iliac artery flow limitation. Makes sense. I definitely agree with them. So now I don't necessarily agree that only the recovery is what's being affected, but surely the recovery is being affected as well. And we actually have some data here from a cyclist who had a stenosis, so narrowing of the arteries as well on one side. And we actually have pre and post-op data. So they did an operation to relieve the stenosis, to alleviate this problem. And so what you have is the two orange lines is the pre and post, the pre-op left and right leg, and the dotted line is the left leg, which is the affected leg. And you get a very similar picture as we saw in the previous paper, that you have this affected leg kind of goes down a little bit, flattens out, and the unaffected leg goes down, and you kind of get this consistent drop and drop and drop and drop. But everything happens much slower, and it goes down much further. And then once after the operation, you actually get the left and the right leg look almost the same, and they look much closer to the pre-op unaffected leg. So if you're going to assume the unaffected leg pre-op was the healthy leg, you kind of get the same thing duplicated now in both legs. So you could say, well, successful operation, left and right leg seems to be the same thing. And apparently, it becomes obvious that the stenosis had an effect, and that was shown by the NIRS data. The stenosis is going to have an effect, and the NIRS data shows that. And it looks like it has an effect here. So, okay, yeah, if you plotted the recovery curves here, you'd actually also see that there's a slower recovery in the pre-op affected leg, and that equalizes after the operation. But you also see that the range on the SMO2 scale is you get much further down, so it desaturates much further for the same intensity. So it's the supply, the balance between oxygen supply and demand here is not equal between the left and the right leg, is what we're seeing. And what's interesting with this data from that I've presented here, again, thank you, Yuri Dostal, for this data, But also the study is that the very first thing, and some people think it's obvious, but I don't think it's so obvious that this is that we can assess this so easily using NIRS, is that you can look at right and left differences of a cyclist and that those exist. And these cases like this are irrefutable that NIRS is working, because you know there has to be a difference. And you see, especially in this pre-post-op data, that there's a change now with the effect of the operation. So we can use NIRS to really assess right and left differences, which is amazing in my opinion. I mean, there's not very many, I don't know any technologies that can so rapidly do this at a physiological level. So you can assess this, and then you can try to deal with it. Now, how are you going to deal with right and left differences? Okay, well, in this case, an operation. There's an obvious problem, we get an operation, problem solved. If there isn't an obvious problem, it becomes more difficult why that's happening. Now, there's papers out there that look at right and left differences. There's by Cooper, there's a speed skating, short track speed skating paper that show right and left differences. Speed skaters kind of circle in one way. There's going to be different effects physiologically, because you're skating the same way, and the left and the right leg aren't going to do the same. So, I don't know, maybe they need to skate the other way. If there's, if this kind of balloons into a big disproportionality, maybe it's bad, maybe it's not bad. I mean, maybe it doesn't matter. Maybe there's no health effects and there's only performance benefits. Maybe you want that imbalance. But if you don't, then you can look at it from a NIRS perspective and see, is there some physiological effects that are happening? And then you can start at least trying to make decisions as to how you're going to assess this problem. You've assessed the problem and how you're going to deal with it. There you go. That's my NIRS rant. I would just like to encourage that people, hey, if you have two NIRS devices, look right and left. You can figure out, you can look at differences. There's no differences, go for it. Easiest check that right and left differences, that you can measure right and left differences. You can do one-legged squats on one or the other leg. You're only going to have the desaturation in the one leg, so it definitely works. And it works. I mean, here, these are clinical settings, and you get some very interesting data. I hope that helps. I hope that also was interesting for the person who left me the comments. So thank you very much. Bye.